23. Inverse hyperbolic functions. Hyperbolic functions. Inverse hyperbolic functions. First one, function, domain, range. Function, domain and range. First one, sin h inverse of x. Sin inverse hyperbolic function. Sin inverse hyperbolic. This domain is R and range is R. Second one, cos h inverse of x. Cos hyperbolic function. Cos domain is closed interval 1 to infinity and range is closed interval 1 to infinity. Hyperbolic function of cos inverse. Hyperbolic function cos h inverse of x is equal to this closed interval 1 to infinity, closed interval 1 to infinity. Next, tan h inverse of x. Inverse function of tan hyperbolic function, that is tan h inverse of x. Tan h inverse of x, open minus 1 to 1, open minus 1 to 1 and this range is up. Once again you see, sin inverse function of sin hyperbolic function, inverse of sin hyperbolic function, sin h inverse of x, this domain is R and range is R. Inverse of cos hyperbolic function, cos h inverse of x, domain closed interval 1 to infinity open and range closed interval 1 to infinity open. Tan inverse of hyperbolic function, tan h inverse of x is equal to open interval minus 1 comma 1 and range is R. Next, fourth one, cot h inverse of x. Cot h inverse of x. This domain, cot h inverse of x, domain is open interval minus infinity to minus 1, union open interval 1 to infinity. Cot h inverse of x, domain is minus infinity to minus 1 open interval, union 1 to infinity open interval, and this range minus infinity to 0 open interval, union 0 to infinity open interval. Cot inverse hyperbolic function, cot h inverse of x, open interval minus infinity to minus 1, union open interval to 1 to infinity. Here this one open interval minus infinity to 0, union 0 to infinity is the range of the cot h inverse of x. Next, fifth one, secant h inverse of x, that is inverse hyperbolic function of secant h inverse of x. So this value 0 to 1 closed and closed 0 to infinity, closed 0 to infinity is this range. Next, sixth one, this is hyperbolic function of cosecant inverse of x. Cosecant inverse of x, this is minus infinity to 0, union 0 to plus infinity. Minus infinity to 0, union 0 to plus infinity. And this range is also minus infinity to 0 and union 0 to infinity. These are the inverse hyperbolic functions and their domains and ranges. Sin h inverse of x, domain is R and range R. Cos h inverse of x, domain closed interval 1 to infinity open and range closed interval 1 to infinity open. 1 closed, infinity open. Tan h inverse of x, domain minus 1 to 1 open interval and range is R. Cot h inverse of x, domain open interval minus infinity to minus 1 union 1 to infinity. Range minus infinity to 0 union 0 to infinity. Secant h inverse of x, this is 0 to 1 closed 0 to infinity. Cosecant h inverse of x, minus infinity to 0 union 0 to infinity. Minus infinity to 0 open union 0 to infinity. These are the inverse hyperbolic functions, their domains and ranges. Here domains and ranges of some other functions. Domain and ranges of some other functions. Here first one, function, domain, range. Here domains and ranges of some other functions. Suppose function is like this, root over a square minus x square. Function is like this, root over a square minus x square. So what is the domain? Domain is minus a to a, closed interval. What is the domain here? Minus a to a is the domain. And what is the range? Range is 0 to a. Range is 0 to a. And also second one, 1 by root over a square minus x square. 1 by root over a square minus x square. This domain is open interval minus a to a. This domain is, this function domain is open interval minus a to a. And what is the range? Range is closed interval 1 by a to infinity open interval. The range is closed interval 1 by a to infinity. And third function is like this. Third function is root over x square minus a square. Root over x square minus a square. Third function is root over x square minus a square. This domain is minus infinity to minus a. This is open interval. This is closed interval. Union a to plus infinity. So root over x square minus a square domain, open interval minus infinity to minus a, closed interval, union closed a to infinity open. This is the domain of the function. And range of the function. This range of the function, closed interval 0, closed interval 0, infinity open. Infinity open. And this one, fourth one, this is 1 by root over x square minus a square. 1 by root over x square minus a square. This is minus infinity to a, minus infinity to a, open interval minus infinity to a, minus a open interval union a to infinity open interval. This is the domain of the function, and 0 to infinity is the range. 0 to infinity is the range. Next, fifth function. What is the fifth function? Fifth function is root x. F of x is equal to root x. Then root x domain is open interval 0 to infinity. Root x domain is closed interval. Closed interval 0 to infinity, and this range is also closed interval 0 to infinity open interval. Next one, a cos x plus b sin x. Here sixth one, a cos x plus b sin x plus c. This range minus infinity to plus infinity, this domain minus infinity to plus infinity, and range is c minus root over a square plus b square, comma c plus root over a square plus b square. This is closed interval. C minus root over a square plus b square, c plus root over a square plus b square, closed interval. Once again, sum of the functions, root a square minus x square. This domain is closed interval minus a comma a, range closed interval 0 to a. And second function 1 by root over a square minus x square. This domain is open interval minus a comma a, and range closed interval 1 by a comma infinity. Third function root over x square minus a square. This domain is open interval minus infinity to comma minus a closed union closed a comma infinity. This range is closed 0 to infinity open. Fourth one, 1 by root over x square minus a square. This domain is minus infinity to minus a open union a to infinity, and range is 0 to infinity open interval. Root x domain closed 0 to infinity open, and this is closed 0 to infinity open. This a cos x plus b sin x domain is minus infinity to infinity open, and closed range is closed c minus root over a square plus b square comma c plus root over a square plus b square closed. These are the sum of the functions with domains and ranges. Sum of the functions with domain and ranges. Okay, all of you. That's all. Here we have the one more problem on functions. The domain of f of x is equal to modulus x minus 2 minus modulus of x minus 5. So here f of x is equal to mod x. This domain is what? Domain is R, and the range is what? Range is closed interval 0 to open interval is the range. So here we have given f of x is equal to modulus x minus 2 minus modulus of x minus 5. So this domain is R. So we have the option 4 is the answer. Okay, all of you. That's all. Here we have the one more problem on functions. Domain of 1 by 6x square minus x minus 1 is. So we have, this is 1 by 6x square minus x minus 1. This 6x square minus x minus 1 greater than 0. Greater than 0. This value greater than or equal to, greater than or not equal to 0. So here 6x square, this can be written as 6 into minus 1 minus 3 into 2, 6x square minus 3x plus 2x minus 1. So these factors are, this is 3x common, this is 2x minus 1. So plus 1 common, 2x minus 1. So this is 2x minus 1 common, 3x plus 1. So this value x is equal to, if x is equal to 1 by 2 and x is equal to minus 1 by 3, so substitute, this is not valid. So we have r minus, this is 1 by 2 comma minus 1 by 3 is the r minus, this is the option 2 is the answer. Okay, all of you. Domain of this is, dear viewers, we have the problem, one more problem, functions JEE MSET level 1. The domain of f of x is equal to x square minus 5x minus 16 by x square minus x minus 6 is. So we have to find the domain of this one. So here we have given the function f of x is equal to x square minus 5x minus 16 by x square minus x minus 6. Here denominator is not equal to 0 here. Here denominator not equal to 0. If denominator is equal to 0, this is not defined. So we have take x square minus x minus 6 not equal to 0. That is x square plus 3x minus 3x plus 2x minus 6 not equal to 0. So x of x minus 3 plus 2 of x minus 3 not equal to 0. This is x minus 3 into x plus 2 not equal to 0. X minus 3 not equal to 0. X is not equal to 3 and x plus 2 not equal to 0. X is equal to not equal to minus 2. So we have the all real numbers domain of f of x is equal to r minus of, this is 3 comma minus 2 comma 3. This is the domain of the given function. Okay, all of you, that's all. Here we have one more problem. The domain of f of x is equal to 3 power x plus 3 power minus x by 3 power x minus 3 power minus x is. These are the options are given. So we have f of x is equal to what? This is 3 power x plus 3 power minus x by 3 power x minus 3 power minus x. So here denominator not equal to 0. Denominator not equal to 0. That is 3 power x minus 3 power x not equal to 0. 3 power x not equal to 3 power minus x. 3 power x not equal to 1 by 3 power x. Then we have, this is implies 3 power 2x not equal to 1. This can be written as 1 can be written as 3 power 0. Okay, all of you. So this is 2x not equal to 0. So x not equal to 0. In this, if x not equal to 0, this condition is satisfied. The domain is total r values, but x is not given. So if you take the number line, this is 0. These are the positive side. These are the negative side. But number 0 not taken. So here what is the domain of this one? Domain r minus 0. Or this can be written as open interval minus infinity to 0 union 0 to infinity. So this is the answer. So we have the option 2 is the answer. Okay, all of you. That's all. Here one more problem on functions. the domain of f of x is equal to 1 by mod x plus x is. So here we have given that is f of x is equal to 1 by mod x plus x. Okay. So here denominator not equal to 0. Denominator not equal to 0. If denominator equal to 0, this is not defined. So we have denominator is not equal to 0. That is mod x plus x not equal to 0. Okay. If here mod x is equal to x, when x greater than 0, mod x greater than 0, this will be 2x. This will be 2x. So if x less than 0, mod x is equal to minus x, this will be mod x plus x equal to 0. Okay. So this mod x greater than 0, this is 2x not equal to 0. So we have take the values x greater than 0. If x is equal to 0, if x is equal to 0, then mod x plus x equal to 0. But we have mod x plus, we want mod x plus x not equal to 0. So here you see number line, this is 0, x greater than 0, x less than 0, x equal to 0. So this value, this is x greater than 0, x less than 0, this is x is equal to 0. So these two not valid, only x greater than 0. X greater than 0 means what? Implies open interval 0 to infinity. X take the values, this is 0 to infinity, open interval 0 to infinity. So we have the option 2 is the answer. Okay, all of you. That's all. Here one more problem on functions, domain. So here we have given the domain of f of x is equal to 2x plus 1 by 2x cube plus 3x square plus 1. Here we have the denominator f of x is equal to 2x plus 1 by 2x cube plus 3x square plus x. Here numerator you observe takes all real numbers. Denominator you observe, denominator should not be 0. That is 2x cube plus 3x square plus x equal to 0. This will be not defined. So this is x common, 2x square plus 3x plus 1 equal to 0. X of, this is 2x square plus 2x plus x plus 1 equal to 0. Then x equal to 0. This is 2x as common. This is x plus 1. Plus 1 common. X plus 1 equal to 0. X plus 1 into 2x plus 1 equal to 0. And x is equal to 0. X is equal to minus 1. X is equal to minus 1 by 2. So you observe this is the number line 0 and this is x greater than 0. This is x less than 0. In x less than 0, x not take the value 0. So x not equal to 0 and x not equal to minus 1, x not equal to minus 1 by 2. If you give these values to this denominator, the denominator should be 0. So this domain is not defined. So here x equal to 0, not take, x is equal to minus 1, not take, x is equal to minus 1 by 2. So here minus infinity to minus 1 union, this is minus 1 to minus 1 by 2 union minus 1 to minus 1 by 2 to 0 union 0 to infinity. This is the domain of the given function. Do you understand all of you? This is the domain of the, this is option 4 is the answer. Option 4 is the answer. Dear viewers, we have the one more problem on domain of the functions. So domain of root over 1 minus 2x minus 3x square is, so f of x is equal to root over 1 minus 2x minus 3x square. Here we have to find the domain of this one, means this should be greater than 0. Positive greater than 0 or equal to 0. If less than 0, then this is imaginary number. If greater than or equal to 0, this is real number. So 1 minus 2x minus 3x square greater than or equal to 0. Then here 3x square, you can multiply with minus on both sides. 3x square plus 2x minus 1 less than or equal to 0. 3x square plus 3x minus x minus 1 less than or equal to 0. This is 3x of x plus 1 minus 1 of x plus 1 less than or equal to 0. This is x plus 3 x plus 1 into 3x minus 1 less than or equal to 0. But we know that x minus a into x minus b less than or equal to 0. X belongs to closed interval a comma b. So here also x belongs to closed interval minus 1 comma 1 by 3. So we have the option 2 is the answer. Okay, all of you. That's all. Here we have the one more problem. The domain of f of x is equal to root over 1 minus mod x. So here we have given f of x is equal to root over 1 minus mod x. So 1 minus mod x should be greater than or equal to 0. If it is less than 0, then we have the no answer. So 1 minus mod x should be greater than or equal to 0. So here this mod x is equal to x. Mod x is equal to plus x if x greater than 0. Mod x is equal to minus x if x less than 0. F greater than 0, x is greater than 0, mod x is equal to x. X less than 0, mod x is equal to minus x. If it is x less than 0, this will be minus x. 1 plus 2x greater than 0. 1 plus x greater than 0. So here first you take this condition. So 1 minus x greater than or equal to 0. Then 1 greater than or equal to x. So x less than or equal to 1. X less than or equal to 1. Next, if you take x less than 0, this is x greater than 0. X less than 0, the 1 minus x less greater than or equal to 0. That is 1 plus x greater than or equal to 0. This is x greater than or equal to minus 1. X greater than or equal to minus 1. Here x less than or equal to 1. So you take number line. This is 0. This is x greater than 0. This is x less than 0. This is minus 1. This is 1. X less than or equal to 1. X less than or equal to 1 means this value. X greater than or equal to 1. This value. X greater than or equal to minus 1. This value. That is x is in between minus 1 comma 1. If you substitute this in this, x is equal to minus 1. So this will be 1 plus 1, 2. It is real. And x is equal to 1 root over 0. So x belongs to closed interval minus 1 comma 1 is the answer. So option 1 is the answer. Okay, all of you. That's all. Here we have the one more problem on functions. The domain of f of x is equal to 1 by root over x square minus 4e. So here f of x is equal to what? 1 by root over x square minus 4. So here this should be always positive. If negative, this is imaginary number. If 0, this is not defined. So x square minus 4 is greater than 0. That means x minus 2 into x plus 2 greater than 0. Here you write the number line. This is 0. This is 0. Here x minus 2 greater than 0. This is minus 2. This is plus 2. Okay. So x greater than 0. A greater than 2. X greater than minus 2. That means here this one and this one. So x belongs to minus infinity to minus 2 union 2 to infinity. If the takes value in between these two, this is the negative, this is the negative, then this is the imaginary number. Also, we take minus infinity to minus 2 union 2 to infinity. So, option 4 is the answer. Okay, all of you. That's all.